This is FRQ topic 4, symbolic manipulation. So these are the directions. This is all no calculator. Directions for this topic. So the domain is always assumed to be the set of all real numbers for which the function is a real number. Angle measures are assumed to be in radians. Solutions to equations must be real numbers. Determine the exact value of any expression that can be obtained without a calculator. For example, log base 2 of 8. You don't leave it like that. You need to write that as a 3, okay? Because 2 cubed is 8, so that value is 3. Do not leave it cosine of pi over 2. Cosine of pi over 2 is 0, so you have to write it as 0. Sine inverse of 1 is pi over 2, so write it as pi over 2. Don't leave it sine inverse of 1. Okay? So in other words, you have to simplify when possible. If you can determine it without a calculator, you need to determine it. Okay? All right. Unless otherwise specified, combine terms using algebraic methods and rules for exponents and logs where applicable. So do not leave it 2x plus 3x. You combine that as a 5x. Do not leave it as 5 squared times 5 cubed. That would be 5 to the 5th, which would be whatever that is. Okay? All right? So you would write that as, because this can be determined without a calculator, you would need to go and determine it. All righty? Gosh. That would be 625 times 5, 3125, I think, 25 to, I think that's right. So anyway, so you simplify it, okay? This would be x to the 3rd. This would be ln of 3 times 5. That would be ln of 15, okay? So you have to reduce, you have to combine on these, okay? All right, on this FRQ, you're asked to solve equations and simplify expressions. This is the FRQ that they figure out if you know how to do those things, okay? You're using log properties, exponent properties, trig identities. You're going to need trig values. You're going to need inverse trig values. Let's do a couple, get a feel for these. We're going to start with number 1 on your sheet, in your packet, number 1. Okay, this, in part A, they give us G, they give us H. Rewrite G as a single log without negative exponents or in any part of the expression. Okay. Your result should be in the form ln of an expression. Okay, so for part A, g of x is equal to 3 log x minus 1/2 log x. Alrighty. Well, we want to write this as ln of some expression. They tell us that. It should be in this form, right? I can think of this a couple of different ways, actually. Since these are both just plain ln of x, these are both just plain ln of x. The arguments are the same. I could just combine these first. 3 minus 1/2. 3 minus 1/2 is 5/2. So that's 5/2 ln of x. Now I can take the coefficient and move it to the power on the argument, and we get ln of x to the 5/2. And that is in the form ln of some expression. ln of some expression. So we're done with that one. Part 2. Rewrite H as an expression in which cosine appears once and no other trig functions are involved. So in other words, we want to clean this up. So h of x they give us is sine squared x minus 1 over cosine x. Okay? Well, up in the numerator, I see that sine squared with a 1, and I'm thinking in my mind, sine squared plus cosine squared is equal to 1. That's what I'm thinking. So I need sine squared minus 1. So to get sine squared minus 1, I'm going to subtract the 1 to the left and subtract the cosine squared x to the right. That would give me sine squared x minus 1 is equal to a negative cosine squared x. So that means I can replace the numerator with negative cosine squared x. Okay? Now, I can reduce these two as long as I don't lose that whole. If you reduce these and just reduce, so I'm going to reduce and it'll leave me a negative cosine x, but this is not exactly the same as that. These two lines are not exactly the same because this has a whole and this does not. So I need to say if cosine of x is not 0. Okay? So that's part A. Part B. In part B, the functions j and k are given by these two. Solve j of x is equal to 0 for x is on this interval. So I'm going to take j to sine x cosine x minus cosine x, and they tell me to make it equal 0. And I want to solve it for values of x between 0 and pi over 2. So we're solving this function, this equation now. So let's see. I'm going to factor out a cosine x. And now I have two things being multiplied to get 0. So either cosine x is 0 or 2 sine x minus 1 is 0. Alright, well cosine is 0. For what values between 0 and pi over 2 is cosine x 0? That would give me x is pi over 2, right? For this one, I would have 2 sine x is equal to 1, sine x is 1/2. What value of x between 0 and pi over 2 is sine 1/2? That would be when x is pi over 2. So x is equal, I'm sorry, pi over 6. I was looking at that answer. So x is pi over 2 and pi over 6. So the second part of this one, solve k of x is equal to 3e. So I'm going to take that and make it equal 3e for values of x in the entire domain. So we're not restricting it like we did in part 1 there. Okay, I think I'm going to come up here and do this part. Alright, I'm taking k of x and setting it equal to 3e. Okay, I'm going to add e to the other side. Divide both sides by 8. Okay. Okay, now what? Now what? Well, I need to get x by itself, right? X by itself. So I'm going to ln both sides. So I'm taking ln of both sides. And that's how I get the 3x by itself. And now I'm going to divide both sides by 3. Divide both sides by 3. Okay, so now the question becomes, now I know that's a good answer, but my question is, do I need to simplify this? Is there any way to simplify that? Do I want to simplify it? I am fairly certain that I would go ahead and get credit for this as is. But if we do split this up into 2 logs, because if the argument is a product, we can split it up into 2 pieces, right? ln of 1/2 plus ln of e. And ln of e I know is 1. I know that is 1. So now x is 1/3 ln of 1/2 plus 1. Is this any cleaner than that? I really don't think so. I think I could have stopped right here and been fine. Let's go on to part C. Part C. Now another function m is given by this. Find all input values in the domain of m that yield an output value of 9/2. So I'm going to take m and set it equal to 9/2. Okay? And find all the values in the domain of m. So I have cosine of 2x is equal to, I'm subtracting 4 to the other side, I'm going to get 1/2. All right. Now, we're solving that equation. We did this at some point back in January probably. Okay, so I take my argument, and let's think about that. Cosine is 1/2. Cosine is 1/2 at pi/3, but it's also 1/2 at 5 pi/3, right? So if we take that pi/3, add 2k pi, that will get me all of those. But then I also have 2x is equal to 5 pi/3 plus 2k pi. I should scoot that over. I don't know why I started way over here, and that's silly, but I'm going to fix that over here. Okay. All right. I'm dividing both sides by 2, which means multiplying both sides by 1/2, and I get x is equal to pi/6 plus k pi. Here, I'm dividing both sides by 2, multiplying both sides by 1/2, and I get x is equal to 5 pi/6 plus k pi, where k is any integer. That's how we need to do that one. I'm sure you didn't like that, but there you go. Now we're going to do the very last one in your packet. This is the one from 2024. Okay. The KHS average was 1.2. The Texas average was 1.1, and the global average was just a very, very tiny 1.3. That is very small out of the 6 possible points. So clearly the kids did not like this problem that year. Okay, part A. Here's G and H. Set G equal to 10 and solve for x. So part A. Set G equal to 10 and solve for x. E to the x plus 3 is equal to 10. Solve for x. So I'm going to ln both sides. When we ln both sides, I get my argument, my exponent is equal to ln of 10. And now subtract 3 to the other side. Okay? We're done, because we cannot do anything with ln of 10. So we're done with that part. Part 2. set h equal to pi over 4 and solve for x. Set h equal to pi over 4, solve for x. So let's see, arc sine of x over 2 is equal to pi over 4. Okay, that means, so what argument makes arc sine pi over 4? That would be the angle that makes sine, or sine of pi over, sine of arc sine of pi over 4 is what? Sine of pi over 4 is what? So sine of pi over 4 we know is square root of 2 over 2. So that will be our argument. That's our argument. Think of it as I'm doing sine of both sides. Sine of both sides. Right? Okay. So now multiply both sides by 2 and we get x's square root of 2. We're done. Not terrible, maybe? Maybe. Okay, part B. J and K. Rewrite J as a single log base 10 without any negative exponents. Your result should be log base 10 of something. So I'm taking J and we're going to combine our logs. Now I am rewriting J. That is not necessary to do. You could just go ahead and write your answer if you knew what the answer was right now. Okay, so I can put these as one log. This one is ready to go. This one is ready to go. This one is not ready to go because I need to move that 9. So I'm moving that 9 to the power on the x. Okay? And again, you don't have to rewrite this if you just see what you're going to need to do. Okay, now we can combine this, make it log base 10. We're going to make it a single log. If the argument is with a positive log, it goes in the numerator. If the argument is with a positive log, it goes in the numerator. If the argument is with a negative log, it goes in the denominator. So we have 8x to the 5th times 2x squared divided by x to the 9th. And now we have to clean this up. Okay, 8 times 2 is 16. X to the 7 over x to the 9. Now reduce your x's. So it said no negative exponents. So do not bring this to the top and give it a negative exponent because it said no negative exponents. Okay, leave it on the bottom with a positive exponent. We're done right here. Okay. Write k as a single term involving tangent x. Write k as a single term involving tangent x. So here's k. There's k. And once again, I see in the numerator a form of that Pythagorean identity. I know sine squared plus cosine squared is 1. So I have 1 minus sine squared. This time I'm subtracting the sine squared over. I'll have a positive cosine squared. So this is the same as cosine squared. So this is equal to cosine squared x over sine x secant x. We're multiplying by that, right? Secant x is 1 over cosine x, right? I can reduce a cosine x I can reduce a cosine x and it becomes cosine x divided by sine x, as long as cosine x is not 0. If you get rid of a denominator, write that. And that is equal to tangent x. Okay? I'm sorry. It's not tangent x, it's cotangent x. Goodness. That's cotangent x. They tell me to write it as a tangent x, so I'm going to change that to 1 over tangent x. Alrighty. Part C. Here's another function m. Find all the values in the domain of m that yield an output value of 0. Cosine inverse tangent of 2x is equal to 0. Okay, I'm going to begin by taking cosine of both sides. Cosine of both sides will get rid of this inverse cosine. So cosine of both sides. Cosine of 0 is 1. So I need all of the arguments that make tangent 1 in the domain of m, so we're going to have to get k involved again. So where is tangent 1, you guys? Tangent is 1 at pi over 4 and 3 pi over 4. That's pi over 4, right? And since this is like the same angle but over here, we're adding pi, right? We're adding pi there. So 2x, I pull down my argument, is equal to pi over 4 plus k pi. Because if we keep adding pi, if you keep adding pi, you get another one that works, right? Now multiply both sides by a half. And we're done. Always say what k is. Alrighty, so that is symbolic manipulation. Solving equations, basically solving and simplifying expressions and equations.